In this experiment, we are going to implement a low pass IIR filter and a high pass IIR filter. IIR filters are digital filters with infinite impulse response. Unlike FIR filters, which was the past experiment, they have the feedback and are known as recursive digital filters. For this reason, IIR filters have much better frequency response than FIR filters of the same order. Unlike FIR filters, their phase characteristics is not linear, which can cause a problem to the systems which need phase linearity. For this reason, it is not preferable to use IIR filters in digital signal processing when the phase is of the essence. Otherwise, when the linear phase characteristics is not important, the use of IIR filters is an excellent solution. There is one problem known as a potential instability that is typical of IIR filters only. FIR filters do not have such a problem as they do not have the feedback. For this reason, it is always necessary to check after the design process whether the resulting IIR filters is stable or not. So in this IIR filter design, we have a 15 passband ripple, a 60 stopband ripple, a 1500 passband frequency, 3000 stopband frequency, and a 7000 sampling frequency. The resulting IIR low pass filter is this. As you can see, the magnitude response of the IIR filters stoops down now to check whether the resulting phase response is equal to the high pass filter. We can enter the same values as you can see, the magnitude response of the IR filter with a high pass filter, we can see that the line stoops up, then normalizes after 0.1 normalized frequency. We can compare this to the low pass filter, that we can here in the low pass filter we can see that the line stoops down after 0.1 frequency, but the resulting phase response of the IR filter is the same in both high pass filters and low pass filters. In conclusion, we can see that the low pass filters only records signals when it is below the cutoff region, whereas in the high pass filter it only records the signal when it is above the high pass filter, the cutoff region, but the resulting phase response is still the same. These filters are very important in digital signal processing since it removes undesired components and keeps only the required signal. During the transmission of a speech signal across a channel, noise of a random nature will superimpose on the original signal, and filters are used to remove this noise as well as extract relevant information from the signal. Digital filters with infinite impulse response are fundamentally different from FIR filters in that they constantly require feedback. Each IIR filter output sample is dependent on both previous input samples and previous filter output samples, unlike FIR filter output samples, which are solely dependent on past input samples. The ability of IIR filters to remember previous outputs is both a blessing and a drawback. Perturbations at the IIR filter input, like all feedback systems, can cause the filter output to become unstable and oscillate endlessly depending on the design.